Hello everybody, I'm Nick, and in this video I'm going to introduce you to the brand new timer introduced in .NET 6 and show you how you can use it both in ASP.NET Core applications and .NET applications, explain how it differs from the existing ones. Yes, there's more than one, actually there's 5, and show you some best practices and explain how some manual approaches to achieve the same thing could actually be bad. If you like this type of content and you want to see more, make sure you subscribe, ring the notification bell. And for more training, check out nickchapsas.com. All right, so I did mention that we had 5 different timers. Yes, 5 different timers in .NET. We have system.threading.timer 1. Then we have system.timers.timer because yes. And then we have 3 more which are framework specific. So this one is for WinForms. I think this one is for Web UI. And this one, I have no idea, but they exist. They're there. You can use it. In fact, in a .NET 6 application like this one, you have these 2 still. Now, all of them, according to Microsoft, are not modern. They're using callbacks. They can lead to memory leaks. They are an outdated design of the past with their eventing and all that. I've talked about how eventing is a bit outdated. So they introduced a brand new one in .NET 6, and they call it PeriodicTimer. Now this one works completely different than anything that they had before. And before I show you how this one works, I'm going to show you what many people actually tried to achieve manually before this was added. So what I can do is go ahead and create a new class, and I'm going to call that repeating service. And this service is going to extend the background service class. Now, this is an ASP.NET Core specific class because we are in an API, or this is a minimal API effectively. So what I can do is implement its one member called execute async. And now to achieve a repeating background task effect, I could have a while loop here and say while stopping token is not cancellation requested, then do something. So I might do some work. In this case, I'm going to just print the date. So I'm going to say date time now to string and use the ISO string. And then I'm going to await task.delay for 1 second. So I'm going to repeat this task every second. I'm going to pass cancellation token and I'm going to use async here. And now what I can do is go back here in the services and say builder.services.add hosted service and use the name, so repeating service. That's it. And now with that, I have full dependency injection. So if I wanted to, let's say, inject a logger here, I could say logger of repeating service, and I could have it be injected from the constructor. This will all work, which is great. And I will have a background repeating task. So as you can see, every second this will print. Now I want you to see something here. As this is going every second, you can see that we're losing a few milliseconds, and it makes sense because when you're awaiting something, you know, that state machine has to resume and that takes some time. And as you can see, it doesn't repeat on the starting millisecond number, the 64, it repeats on the rollover. So 91 now, it's going to be 92 now, then it's going to be 93, 94. And in a big enough duration, you're going to lose some seconds. But when you're working with a timer, you want the timer to be based on the starting time. That's a very important thing. So this approach, even though it looks fine on surface level, not only can it lose time and be pushed forward, but also if I extract this method over here and I rename it to do work async, and I turn this into a proper async method, which I also await, so async task over here, and I simulate that the thing that I'm doing here, let's say I'm pushing in a database, I'm reading from a database, I'm reading from a message bus, I'm pushing to a message bus. You could be doing many things. Let's simulate that by saying task.delay for half a second, because the operation we're doing takes half a second. Then when I run this, the timer isn't on 1 second, it's 1.5 seconds, which we don't want. That's catastrophic. That completely destroys the point of having a timer. So if you're using this for a timer, bad. Now let's take a look at the brand new class added, and that is, and I'm gonna go ahead and delete that, the periodic timer. I'm just gonna call it timer here, and I'm gonna instantiate it simply with its one parameter, which is the time span you want it to be triggered on. So I'm going to say from milliseconds again, 1000. And now I'm still going to use the same background service shell, but I won't have any of that. All I'm going to have is a while timer, wait for next tick async and pass the cancellation token. And I'm going to wait that. And I'm also going to respect that token, and I'm going to say end stopping token is not cancellation requested. Then do work async. And I'm going to remove this small delay for now and leave it as it is. And now, as you can see, when I run this, it is going to do it every second, but not only every second, it is trying to keep it as close to that original 71.3, 71.4, like 720. It tries to keep it on the same time that it started, which means that even if this thing has a small delay, let's say half a second, so let's go ahead and run it again, then even though the work it does takes half a second, it doesn't push the timer forward half a second. In fact, it doesn't push it at all. Now, it's worth pointing out that if this delay was actually longer than the time span here, then of course it would push it because it is awaiting the thing properly. But I don't know how many people use this type of thing for second to second delays, or they're more likely to have it for a 1 minute, 5 minute, 10 minutes, or like 2 hours type of timer. So whether this will have an effect on you is very situational, but that way you can still have all that dependency injection goodness. So if you want to have an logger of repeating service and you want to inject it and use it, you can still do all that in the constructor and use it here. So this is how you can use the brand new timer in the context of an ASP.NET Core application. However, not everything is an ASP.NET Core application. What if you're just making a console app that doesn't have an ASP.NET Core background service? Well, let's go ahead and see that. I'm going to go ahead and create a new console app over here. So I'm going to say console app. So I'm going to select that and say app over here and create that. And I'm not going to add any dependencies. All I'm going to do is create a brand new class, and I'm going to call that background task. Now, I'm going to use this task as a wrapper for my timer to provide that experience of something taking every n amount of time. So I'm going to have a few things. First, I'm going to have, of course, the periodic timer. I'm going to store that here in a field. I'm also going to have a cancellation token, but for that to exist, I need to have a cancellation token source. So I'm going to say read-only cancellation token source over here, and I'm just going to use CTS. And then in the constructor, I'm going to set the timer to a new periodic timer of a time span. So the time span is what the user can provide, and that's going to be called the interval. So let's pass it down here. That's not how you spell interval, and I love that Ryder knows it. Here we go. Now, the biggest challenge that we have here is that the timer needs to be awaited for every tick. And when you await something in a loop, it means that your program won't actually continue. So this approach in a console app needs to be tackled differently. What I'm going to do is have a couple of methods. I'm going to have a start method, which will be a void. It's not going to be awaitable. And I'm going to have a public async task stop async, and that one can be awaited. Now, because I'm not going to be awaiting immediately my task, I'm going to keep a reference to it here. So I'm going to say private read-only task, and it's going to be nullable to begin with, and call it timer task. And I'm going to actually start backwards. I'm going to start from the disposal of the task. So I'm going to say that when I want to cancel this task, when I want to stop it, then first I want to check if the timer task is null, then return. I don't care about this. Then cancel the cancellation token that could be passed down to other things. So I want to cancel everything else that this timer is calling with that cancellation token. Then I'm going to await the last invocation of that task because it might be doing some work and I want that last one to be completed. And then I'm going to dispose the CTS, which is the cancellation token source. And then let's just, for our benefit, print something in the console. So write line task was canceled, just so we can see it being canceled. And I have the start, but what I want to add here in the middle is add a private async task, and I'm just going to call that do work async. And this will be where I put my logic. Now you could, if you wanted to, expose a delegate on the start and pass it down and run it through that way. I don't want to make it too complicated. I want to give you a skeleton to build on top of, so I'm going to give it very, very simple. So I'm going to catch the operation cancelled exception, which I don't really care about. And that's that. And in the try, I'm going to say while, I'm going to have my await timer dot wait for next tick async. And I'm going to pass down the CTS token here. And I'm just going to print console.writeLine. And again, I'm going to print the date on the ISO format. And that's it. And now all I need to do to start this is say timer task equals do work async. Now, of course, this can be read-only, so I'm going to remove that. And now this is happy. And now let me just close all that. I can go to the program.cs and I can say, well, first I can say console.writeLine press any button to start task. Then I'm going to have a console.read key to simulate like the starting of the thing. Then I'm going to create the task, the background task. So I'm going to say task equals new background task, and the time span here will be 1 second. And then I'm going to say task.start to start it. And at this point, I'm going to say press any button to stop the task. And I'm going to say task.stop async, and I'll wait that properly. If I could type properly, here we go. And effectively that's it. In the end, this will print from the stop method, task was cancelled. So now if I go ahead and I run this console app over here, it says press any button to start. So I'm just going to press the spacebar. And as you can see now, it is working, and it says press any button to stop the task. And you can see how precise it is. Again, it's the same second to second without any pushback on that original start time. And then if I press anything again, task is cancelled. Everyone is happy, the thing stops. And you can take that code now and have a generic thing where you put some logic here and you run it, and you can inject different things if you want to from the constructor as well. You can register it in DI. You can do so many things, and nothing blocks you here. This still awaits things properly. You keep that original reference and you can stop it, and you can restart it as well if you want to. So I personally really like this new approach on the timer. It's very modern. It's very nice. You don't have to deal with all the callbacks and the event handlers and all that. Everything is very straightforward, and you can read it and follow it way easier, in my opinion. Now, I want to know what you think. Leave a comment down below. Do you like this? Do you hate this? Are you using something else for a timer? Let me know your thoughts. Well, that's all I have for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video. Subscribe for more content like this, ring the bell as well. And I'll see you in the next video. Keep coding.